Let's see if there's anybody on live. It's not the Sony Handycam, it's actually there's a laptop cam, and there is going to be a work cam, and there's also going to be a microscope. Okay, right. So the last time you guys saw me, and if you saw the video of me doing some soldering, I'm still working on my ESP-01 board. I did some work rewiring it so I could try and debug it by connecting some of the different options. So you've got on the ESP-01 board, and let me go and just get it so you can see the thing. So on this board here, as well as power and ground and TX and RX, you've also got the GPIO0, GPIO2, CHPD, which I believe is a chip select and has to be held up, and a reset. And I was kind of pulling some up, pulling some down, and doing it all with a soldering iron. What I did the last video I did, which was actually a recorded video, was I rewired this such that all of those four lines, so GPIO0, GPIO1, reset and CHPD, are wired to a bunch of 3.3k resistors, and then those along here can be pulled up or pulled down selectively. Now, I did actually experiment with it a little bit the other night offline, and I can perhaps start by having a look at what I found. Now, the first finding was I was talking about this strange baud rate, was it 78600 or 76800, and not really getting things to work quite properly, not quite getting things to work in the flasher. Turns out that actually the baud rate I found that did something was the wrong baud rate. It's supposed to be, I think, 74880, and then that means the flasher gets something. But let's start with where I started. So let's get the thing plugged in and get Putty fired up. In fact, actually, I've got a previous Putty session, so I can show you what's been going on, and I'll explain it while I wire this up. There are a number of boot modes on the ESP-01, which choose between going from flash or going from flash or going into a UART mode. I believe there's also an SDIO mode, but I don't know if that's just actually SDIO connections. And I'll go through what I found out and what I researched just by pretty much taking what I saw in a serial terminal and outputting it. So at this point, oh, and the other thing, by the way, is while playing with this the other day, I did manage to take the power LED here out, so this will not light up red. It is on, and there will be blue flickers once we set the CHPD into the right mode. But unfortunately, I left a cable loose connected to ground, and it tapped the side of an LED there, and the smell of popcorn, and the LED hasn't worked since. So I think I kind of, yes, let the magic smoke out of that bit, but the rest of this is okay, so this still will work. Okay, so that's now connected up. Let's go and see. Okay, I'll have the old Putty session, and let me put that where I can see that too. So you'll see all this business about boot modes and so on. First thing is I'll show you the baud rate I'm at. So, oh, it doesn't capture it here. Okay, so the baud rate is 74880. I wonder if I can reconfigure it so it'll capture the actual part there. Give me a okay, right, including search. So this is the actual baud rate here that it's supposed to be at. I don't know if that's clear enough for you to see it. I'm hoping that is, but maybe that resolution is too high. 74880, and so things I captured. So this is obviously wrong baud rate, something like 9600, and this is actually at the correct baud rate, and I've been capturing a lot of this kind of stuff. So these boot modes appear to be based upon well, boot flags, I suppose, coming from the I/O pins as they're set. Now it's going to sit there and not do anything till I connect CHPD, which is the chip select. So until that's connected to VCC, nothing's going to happen at all, which makes me wonder if I'd have thought it out more, that one I'd have soldered straight to VCC. And I even went and reviewed my old original videos where I got this particular ESP-01 working then, which was what I did there. I just connected that same line up to VCC. And what I found with these, so I went and had a look around online to find out what those boot modes meant. And again, I'm not sure if you can see this clearly. So github.com/ESP8266/Arduino/blob/master/doc/boards.md, and under there is a boot messages and modes. I will put that in the description, but I will also put that in chat now, so people can also have a look at that. And oh, this one here. So this talks about how boot message and mode. ESP checks at every boot the pins 0, 2 and 15. So the first thing is only 0 and 2 are broken out on this board. 0 and 2 and 15. Okay, and you get reset cores, N, boot mode, some other N's. And if I go to my Putty session, let's just pop that on here. Hold on a second. Add existing Putty. I'll just put that there so it can be seen alongside. So we're seeing this reset cores and boot mode. Now reset cores, okay, normal pin, I believe, normal boot. So that's a power has come on or chip select has come on, so the thing's awake. And from there, after the reset calls is these boot modes. So in the Putty session, we've got boot mode 6, and so I think software reset is CHPD. No, sorry, 1 is normal reset. So 3 is the actual flag numbers here, I believe, and 6 is the choice of modes down here, which says SDIO, which for this particular case is not that useful. It doesn't make any sense. Okay, I've got the Putty window on there twice. And let me just switch back to the work in a second. So we've got first here, okay, GPIO2 shifted by 2, 15 shifted by 2, GPIO 0 shifted by 1, and GPIO2. So this is 1, 2, and 4. So 3 is going to be 1 and 2, because this would give me a 4. And I got boot mode 1 and was able to flash stuff, but the stuff I flashed didn't appear to boot. Now, if it's saying 3 here, then that's what, GPIO 2 and 0, so it should be booting off a flash with number 3 here, but it's going to number 6, which doesn't make any sense, because GPIO 15 would be 4, and so I'd expect to see a number greater than 4 here. So what I'm doing here, by the way, is, oh, hello Samuel. I'm just going to drop that down here so I can see the dashboard while people talk as well, because otherwise I can't see that. Let's just put this right. Can I see chat and see what else I've got? Yes, excellent. Okay, just juggling windows a little bit, and we'll go back over to the bit here. So 15 can't be set because I'd expect to see a number greater than 4. So yeah, if it was 7, or something in this first number, then it would be set. So I can say, okay, with some certainty, at least from here, GPIO 15 is not in play and is probably grounded or pulled down or something, which is what you'd expect on the ESP-01. You know, that would make sense. But then how is it arriving at this number 16 if that's the, sorry, this number 6 here if that's the case? 3, 6. It's also possible that I've got a random document from the web and it's not entirely accurate. That happens. So I've had a look around at some of these others, and again, low, high, high, flash, low, high, low. Program via UART. So that boot mode 1 there suggests that it was ready to take from flash. Boot mode 3, it's supposed to have loaded something here, but I didn't see anything pop up, and this is where I'm expecting Node MCU, and I'm expecting prompts. I'm expecting something at either 9600 or 115200 board, but I suppose we could find out what the default is for the version of Node MCU I've got. Now let's probably start by wiring this up and getting it to do something. So let me go back over to the work. Let's tell Putty to restart and we'll clear it because we've got an awful lot of stuff there. There we are. So assuming I've reconnected TX and RX the right way round, which is always a possibility. Hold on, let's put it so Putty's not completely obscuring where my hands are. That's better. Oh, now has it just done that by me? Okay, that's my finger pulling up the reset, the CHPD pin. Right, let's take ground out, and I'll just use these because these are going to be kind of fairly handy. I might also want the drawing I did the other day just so I can actually get a so should have prepared that. Where are my drawings? I have drawings to say which of those resistors is which. Here they are. Right here, we can put that right next to it. Okay. Okay, so I got drawings there that I made in my previous video, basically marking what each of these are. So on a relatively, let's pop this in, make it slightly more permanent than some of the other connections. Okay, so you notice if you look there, it's kind of not quite contacting. I'll tell you what, let's get that in. So I've got another toy in play today, which is this, my microscope. So let's see if I can get the microscope and even better like that. Okay, get some light in and let's take a look there. So that's kind of nice. So is that actually gonna make good contact? So what I was thinking here was I was kind of hoping that pushing this through would be enough, but there's plenty of wiggle room there, and that'll be random resets and all of that stuff. And also that cable there is not actually soldered through to the hole there, so maybe just enough of a dab of solder not to go through the hole but to attach those cables to the holes means those holes would then be suitable for this. Or the other alternative is see if I can just bend that wire over the other one. So let me get some tweezers. I should have those ready too. Set of tweezers. maybe I shouldn't do this with it still connected to the computer partially. So I'll disconnect that. So I'll take a set of tweezers. Maybe if I don't know, bend that down somewhat. If I bend that over that way. That's now up here. Sorry. Let's get that in view. Oh. Okay. So that top rail there, or these two pins up here, are VCC, positive voltage, or 3 volts in fact. So CHPD we want up there. And again, similarly, these through-hole plated things are not necessarily making contact with those leads. I mean, the dabber solder on that one, but this one I kind of got a weak mechanical contact and no welding. So I think it might be a matter of doing just a couple of spots of solder just to make sure those bits are going to be connected, because I don't want to be questioning my connections while I'm debugging other issues. And I hadn't really thought about that in the last video, but after playing with it a little bit last night, I started to realize this could be a flaw. Okay, let's go get this in the bigger one because it's too hard to work under the scope. And push that through there. So instead of using chip select to accidentally reset, I want to really have it all driven. Was there another closer one? No. I'd like to have that just driven by plugging the ground pin in like I was before. It all seemed like such a good idea when I made this particular change to the board. The intention of not having to solder certain connections that I'd want to change, but this particular one, the CHPD, yeah, actually I nearly always want it to be VCC. And I'd probably suggest anyone else working with this that most of the time, unless you've got multiple chips, it sounds like that one always needs to be up. I can even just solder that way, solder that across that leg of that resistor, but for now I will just go for forcing it down. There we go, effectively creating a bit of a cold well. Let's make sure it's not. There we go. Okay, that's in. So now the thing is that definitely at least going to be turned on. And I've knocked my serial dongle off the bottom of the desk. Okay, so we should see some life in Putty. Let's connect everything and we'll connect ground last. I'm probably doing this the wrong way up. I should probably connect ground first and then come back and do the voltage last, but there we go. Sort of somewhat. Okay, so we got two boot modes out there. We're not getting random resets, that's good. But 3.0, 3.0. Now, one of the reasons the boot modes are going to be slightly odd is we are, well, effectively those pins are all floating, GPIO 0 to GPIO 1. So if we go back to, I've got a bit too much going on here, but okay. Back to that document. 3.0. Well, that's suggesting So pins GPIO0 and GPIO2 are grounded. Well, no, because that 3, if that 3 is just the first number, how am I reading this right? So I'm wondering if there's further documentation on how this is written. Number equals. Okay, this is, so do they mean this total number, not just this bit? And which number do they mean? Reset calls, boot mode. The first value respects the pin number. So the first value is 3, which is flash mode. Okay, right. And what about the second value? Oh, well, it doesn't say. Now, maybe if we're just trying to get it to boot off of what's already in flash. Well, look, 3 is booting off of flash. This isn't actually showing an error here. So we're just seeing something about the checksums. It maybe has loaded some sections of memory. So what if I switch baud rate? Hold on, you can't see this. There we are. To 9600. And do we have anything? We don't. There's nothing coming out there. And if I reset at this rate, okay, so that's clearly data at a different baud rate. That's going to be this other data, I suppose. And I suppose we're not seeing in this previous data something that appears to be outside of its baud rate. No, wait a minute, there. That was something on another baud rate. So maybe there is. Let's try 115200. Okay. We'll reset again. LRL, I've seen that before. I have seen that before. And that was potentially maybe when I didn't have anything ready to flash on it. So boot mode 3. So if I pull GPIO0 down, I should be able to flash it. Hence this boot mode 1 up here. But I'm interested also, what's this 6 and what's this 0 mean? Because that's not, at some point I managed to conflate that with this, but that second number, it doesn't actually say what the second number is here. And they're saying 6s. I've got 6s and 0s. Do we have anything? So this is the Espressive datasheet, also downloaded from the Arduino website. And does it say anything about these? So these, okay, tolerances, voltages, input high voltage 3.3. Well, actually for TXRX we're doing a little bit more. Maybe it says about that. So that's about the UART, but that's not quite where we're at. External baud rate is, so 26 megahertz, the baud rate for printing is 74880. So unless we've kind of set it in the software, which I suspect the other software did, that's why we'll be getting things at this rate. Okay, so that is in this data sheet. We're not looking at RF in it, are we? No. Firmware software development kit. No. Features. Power management. No. Okay, we've gone right to the end. Is there anything on the actual GPIO pins right at the top of this? So GPIO 15, which is also interesting, UART RTS. Okay, but that's one of these in play that I think is just being held low. SPI clock select 2 or GPIO 0. UART TX during flash programming. But we've never connected TX to that, which is interesting. Is that right? SPI clock select? I'm presuming that's what that means. It wasn't CLK, it was... let's go back. SPI CS2. What if or maybe that's a chip select. The only reference in the entire document. Okay, I think that was a bit of a dead end. So I've looked at some of these other things, and we're getting similar kind of. I mean, that effectively that is the same table as this table, without going into what those other modes down here are. Bootloader modes and GPIO state on startup. And again, this is that part there as well. Now, okay, that's a bit, that's probably not what we're looking at the moment. I do have my oscilloscope ready in case it's needed. The only big issue with the oscilloscope is there's nowhere to put it behind me, and it's too big to get under this camera. So maybe I'd have to actually lift up this camera and move it round so you guys will be able to see that if we need the scope, to find out perhaps if there's something else going on. Okay, well, one thing we can do, that's interesting. Look, it's still outputted stuff. Nothing's hot. It's not been told to reset while it's doing stuff, but it has. Is that just where I'd... That's interesting. Hold on. I put quite a block. And is that more or less than this block up here? So we went, in the last session, we went around trying different board rates. So I'm not sure that that's entirely, you know, I mean, that's not going to get us much further. We could have a look at what I've attempted to flash on it, or let's go and flash something fresh on it, and then we'll know what we've got. So, okay, so here is the flash tool. I'm going to need to do this. Let's take, that's showing GPIO 2 and 15. Oh, I see, 0 to 15. Okay, right. So let's just make a change over there. We'll take GPIO 0 and pull it down, so that's this one, and bringing it to the bottom here. Again, I'm going to need to go and make sure that that connection is actually being made on the back. So That connection is good. That connection is good enough. Okay, that's going to be making electrical connection in my opinion. And now if we set this back to (74880), we should see we're in mode 1 is my thinking when I connect this up. We're still in mode 3. Now I've said this is GPIO 0, this is GPIO 2. Sorry, you can't actually see that we're still in mode 3. That would help. And I'm just going to switch back over to this mode. So that does suggest we aren't quite getting the contact I want on there. No, I can see it. I can see it's loose going to ground here. Let's just get that out of the way ever so slightly. Can I push those together a bit? Not as much as I'd like. Oh well, actually, what I could do, and now you can't actually see the work. Can I get? Yeah, that's still not going to help much. Okay, let's just go with this for now, and we'll come back to Putty once I've done this. So. That one, we'll come back to this one. Okay. Just got that over here. I'll bend that down over here again so it's got hopefully more electrical contact, and we'll see if we've done that when I reconnect this, and we'll see what boot mode we get. Boot mode 10. Okay, so it's ready to flash. That suggests. Interesting side effect that that LED is going on. That LED is on GPIO 2, which is the one I've not connected to ground. So it's kind of floated upwards. Very, not what I expected anyway. So let's go and put the flash on there. I'm probably going to have to, I presume I'm going to have to disconnect Putty. Putty says it's inactive. It's not really inactive. It's been inactive and on a few times. Okay, so we'll close Putty. And we'll do flash. Oh, hold on. Let's do this so we can see this. It's COM6. It's using some internal version of Node MCU. I don't know which version that is. It's on the right baud rate. And maybe that doesn't think it can get hold of the port. Port connection failed because I probably started this while Putty was running. Let's start that up without Putty running. Okay. Ah, right, we have a MAC address. Okay. Now it's going to be flashing this random version of Node MCU. Okay, and this doesn't actually have a version number. Hurrah! So I don't know how new or old this version of the firmware programmer is. However, I do have some Node MCU, well, some binaries to flash. So we could try one of those if we get no joy with this one. So these are relatively old actually, aren't they? 095 dev 18 modules. So this is one built with the Node MCU build process. You now have to choose your build, choose your bits, and it gets sent to you a bit later. Maybe we'll have more luck with that. But let's let this go all the way through, and I can at least try and connect to that with Putty and see if we can get it to give me a Node MCU session. So when this is finished, when it's done, I'll disconnect that cable up there and retry. I mean, effectively what we want to do is get a prompt and be able to turn on that LED, and then we can try my old code again. You'll notice here I've got a whole bunch of different bits of Node MCU code, and I've also got somewhere in my source repos the original LED server setup that I had from before. Okay. Well, it says it's ready, so okay. Let's close that. Disconnect this. We'll remove our pull down on GPIO2, which should put it in mode 3. And get Putty back. Now, I get the feeling, I could be wrong. Oh yes, okay, that's good. I was ever so slightly worried that I wasn't going to get capture in Open Broadcast Studio because I closed the program. I'm sometimes a bit fussy about that kind of thing. Right, we're in boot mode 3.0, so we're booting from flash. I think this is just it loading what's in memory. There's no error messages in here. So let's switch serial to, we'll try 9600 and 115200 again. So I'm expecting to see junk from the bootloader. So I've got junk from the bootloader, but where is my Node MCU? Now it may be that actually that internal isn't actually a full copy of Node MCU at all. I don't know if that was actually expecting some file to be next door and isn't there, because I've kind of maybe removed it because I've got some newer version here. Let's try 115200 again. This is not looking like this is going to do what I want it to do. Oh, and we then now I think we know that the TX pin works, because I'd imagine that the flasher there would fail if it was transmitting and not receiving any kind of confirmation, right? So, and it got the MAC address, so it has to be doing two-way communication. There's got to be something there. Okay, sorry, we just changed that to 115200. So it keeps opening in the other right. And we'll connect, disconnect, and reconnect. LRL, we are again here. So is there any other baud rate we should be considering? What I will do, I'm just having a quick look to see if, okay, this is talking about doing So it's doing the flash. Now, Node MCU uses 115200 board by default. 30 seconds. Well, I've not left it turned on in that mode for 30 seconds. Surely it would output something in that 30 seconds. Well, it's been on now for 30 seconds. It's not output anything. So I'm not buying that either at this point. I think I'm going to go and try one of these other binaries just because I'm not 100% sure I trust that binary. So we'll close that. Drag up our flasher again. Configure this. And can I just drop? No, how do I? Oh, there we are. Okay. Now, looking at these parameters behind, I do want to load it at 0. Or do I? Hold on. I'm assuming that's the right thing here. But before I do that, we need to disconnect this and pull that pin up again. You can see why I've kind of made this board so I can tinker with these pins, because I knew I'd have to do this a couple of times. I'm sure when I was doing this on a breadboard I did that a couple of times too. It's just it was a whole lot easier to do on a breadboard. I mean, there is records in the old videos of me having pulled up these pins and done things with them. And as I said, I've had a relatively easy ride with these ESP micros until this time, where most things, apart from the initial power problems I had way back when, have just worked. So there is yet the possibility that I have done something and damaged it and it's just never going to boot. But let's give this a go. So I'll connect that up. Oh, what happened there? We not quite getting anything there. Is there any blue light flashes? Oh well, I'll try the flash tool, see what it thinks. No, it's not reached it, has it? Okay. Should probably not have that all connected up while I'm... So I did disconnect it by the other end. That wasn't just... right. Nothing's gotten warm, so that's good. That's a very good sign. It's always a good sign. I'm determined that this weekend this is either going to work or be replaced, but I need to convince myself that there's something utterly wrong with this, and the reason I've got the oscilloscope on standby is in case some of this weirdness is down to me having skimped out on the input filter cap on that power supply. But then, I mean, it is behaving not in the way it behaved before. I'm certain, but it's not behaving so badly that I suspect a dodgy power supply, especially as power supply going to it. I'm kind of thinking it's coming from a PC, so PC's USB port, so I consider that relatively stable. That might be a foolish assumption. Okay, we got a flicker there, and this can find ESP-8266. It's not finding it, which is interesting in itself. I mean, we've still got our, we've still got the right rate. Hold on, might help if you can see that as well. Okay, well, while this is disconnected, let's again pop up Putty. I should so have that pinned, shouldn't I? Use it often enough. And okay, what am I getting from it? Nothing. Have I dislodged my CHPD pin? Is that what's going on? Yes, I have. Well, that would do it. That would give me nothing. This strategy is not, I'm still kind of thinking that the soldering of those would be necessary, which is something I might do kind of later offline. Let's see. Nothing's happening. Oh, there we are. Something's happening. Okay, so these are still really not great connections. These are still very, very much in the realm of being quite iffy. Okay. It calls for some other approach. I mean, my plan of just using resistors, I wonder if I could get a better connection using big fat jumper wires, as in these things, because they've got big square pins. I won't be able to bend them over, but I would think, this is where I could be wrong. Oh, but the problem is they're only going to be making good connection with that through hole plated thing there, not necessarily good connection with the pin behind it. So, all right, let's see if I have the skills. I'll move these out of the way to do what I said I'd do, and see if I can put a tiny dab of solder, just enough to make it so those through holes are connected to both the pins I'm trying to pull up, pull down, and to the ground and voltage. Oh, well, it might help if I actually dropped out all of those first. So I've got everything ready for soldering in case I needed it. And I think not being able to trust those is just not good enough. So let's go get a tiny dab of solder. And in fact, you see, all of these, I can maybe see if I can get just tiny dabs of solder. I don't want to actually close the holes. And you know what else I can do? Because this is all supposed to be ground, I can just clip off this insulation all the way up here, so this is just a great big ground plane across the top there. Cutters. Where are my cutters? See, this might be a job for a blade instead. find easier to do from this angle. I could also just melt it off, but that would probably stink. Oh, and if you're on the chat channel, please do, if you've got ideas on other ways we could approach this, I'd love to hear it. The fact that I've been for a few nights trying to get this thing working means I'm obviously barking up the wrong tree somewhere here. So I'd love to hear how other people would approach a similar problem. Last fiddly little bit. On the positive side, I don't appear to be streaming quite well today. Actually, there's a question about how's my audio and stream quality. It says it's good, but I suppose it's down to you guys to say what you really think. And I'm going to turn on the fan, which means I've just asked that question as it's about to get a lot noisier in here. Sorry about that. Let's see if I can take that. I want it close where I'm soldering, but that also puts it kind of close to the mic. So there's not quite a win-win situation on that, I'm afraid. And let's tin that tip and get that clean. Oh, let's try and keep this in shot. Oh, trying out different module, the same type, testing that module on the breadboard again. Yeah, a different module of the same type was where I was beginning to go with this. And getting this one module on a breadboard, I just want the teeniest bit of solder there. Getting this on a breadboard, I've made it. That's exactly what I didn't want to do. This is cheeky, but if I was to. Okay, that was exactly what I didn't want it to do. So I kind of painted myself into a slight corner. Oh, look there. Okay, let's try it on one more and I'll come and suck those back away. That's what I was expecting to get, is that actually making a connection. It is, I think. I'll test that with a multimeter later. So yes, getting this module off here is going to be tricky because of the way I've kind of soldered it in. But getting another one of the same type and running similar tests on a breadboard may mean that I can see if it's me or the module. See, isn't working terribly well, is it? Yeah, exactly. So in one of those videos I took the headers and soldered it right in on there, so that's why it's kind of not up for being re-breadboarded. I suppose I could still, because most of the rest of this other than power and TX is disconnected, I could still just run those over to things, because I could probably get if I get a female one of these, will it? It's not deep enough, but maybe if I got a less deep one I could do that. Maybe breadboard it up that way somehow. Okay, I guess that's solder sucker territory. Is it going to... This has not quite worked out the way I wanted it to. Okay, let's see. If I just apply, first push this up slightly here. If I can get one of them to work, I can do the others, but I haven't got one of them to do quite what I want it to. I mean, that's the nearest I've gotten. Oh, there we go. That's the nearest I've gotten. Yes, they do seem to be the main hardware thing. Oh, do you know what? I've got another idea. Well, this, I mean, I've got one of these things. What if I was to just go ahead and, at least on a temporary basis, wonder if I could solder those in, or I could solder actually just solder some of these in, because I think those actually work quite nicely. They go, do they? Do they make good contact? Because if I could solder a bunch of those in, I'm just slightly worried if I solder these in I'm going to end up with melted plastic when I try it. But I have got so much of this stuff, it's unreal. So yeah, solder a bunch of those in to these 4 pins up here, the other side of those pull-ups, and then I can remove them when I realise I'm good again and what have you. When I don't know what. You reckon I can solder those without melting them? I think I can, but let's get that out of the way. Let's see what's on this side of the board. Nothing. I've left that nice and clear. So can we push them through? And then when we get it actually running, I don't know, it'd be kind of ugly to leave these in, but on the other hand, it would also be foolish to say, oh, I'll never put new code on this. Nah, it's not going to take a long time, is it? Yeah, you're right. Hold on, what if I solder some headers on? I've got boxes of those. Hold on. If I'm going to stick that in, why don't I just shove some headers on and stick some headers on the other pins, on the rails. Right, where's my box of headers? Because that could be a really quick and easy win here. I think I'd originally said I wasn't going to put headers on because I was going to make it work otherwise, but you know what? I've not. So, there are my normal headers, not the super duper long headers. Of course, it's not impossible. Now I went through a whole bunch of those, but I can only see that. But, and those are my super duper long ones. Just have a quick rummage in the cupboard because I know I had some headers to hand the other week. Oh, did I solder them all? Do I need to order more headers somewhere? That would be frustrating. Found them! Found some! Okay, I might need to go and organise some of my cupboards. Didn't I say that at some point before? Right. Let's take 4 of those off. Let's solder those right in there. And then we can use them. Shorten them some some snips. Okay. This was something I didn't do, but maybe from the outset, if I'd have done it, this would have been far easier because then I wouldn't have to question all this stuff. Oh, back here again. Let's just pop that over there. Turn that around. And use that to prop up the header so it goes in relatively straight as it just falls out from underneath. Hurrah! Oh! Do I have any blue tack handy? Blue tack the top of this in, right? Indeed. Let's just gum that down a bit. The only problem with blue tack is it gets hot, and as it gets hot it tends to lose its adhesion properties, tends to actually become, I don't know, you warm it up in your hands to get it sticky, which is great, but then if it gets too warm it starts to become less sticky and more like runny, frankly. I've not had it actually melt on me, but certainly take on, I don't know, a more gloopy and less and viscous as opposed to solid and sticky property. There we are. Right. Okay. Those are behind here, and my biggest worry at the moment is just making sure that this blue stuff is out of the way. $2 programmer, solder a switch to the back of it, and when you're done programming, use it as a power regulator for the attack devices. Solder them to the top. Haha. Oh, that's an interesting one. So let's, yeah, exactly, the hot air rework station. My only paranoia with the hot air rework station is I'd have to make very certain to try and make sure I don't get the top of the ESP with it. Oh. Because, or at least turn the airflow down quite a way so I don't actually risk any possibility of taking any of the components off the top with it accidentally. Let's just give that a bit more. Okay, that'll do. Right. Oh, I do have the Kapton tape actually. I got a bunch of that around the 3D printer setup. Let's stick 2 of those up here, or down here on ground even. I'll need to repurpose my blue tack. It has gone in wonky, hasn't it? But it's in. So that blue tack didn't hold quite as well as I thought it should, and look, it's kind of gone. Yeah, you. Okay, I'm going to try that trick again. Let's see if I can get this to prop that up. The only problem is it does add to the thermal mass of those as well, but then I shouldn't need to. Going to work, or am I just going to have to prop it on the table? Let's just keep moving extra parts. Yeah, that's a problem for me too. Okay, I'll bend that up out of the way. It was always supposed to be bent out of the way. What if I try? Yeah, that's probably the other thing, is just give the blue tack a while to cool, because it was kind of hot back there. And I can use blue tack to remove extra blue tack. Oh look, that's... Yeah, that would have worked. Anyway, it's what I did the first time, it's just it kind of loosened up as I did the various connections. Okay, okay. Seem to be spending a lot of time soldering the board, and we haven't had much luck programming it yet. Or reprogramming it, since it did once work. Oh, you guys can see, or yeah. Come on. There we go, we've got ourselves a couple of ground pins, so we can ground something. And similarly, I could set these 3 up as 3-volt pins just here. The reason I'd left these loops here was so I could use those and push things through under them, but it didn't entirely work. Actually, it doesn't matter so much with this particular blue one because it's actually going to be connected to the same rail that those 3 pins will be there connected to. Can't get my nail under that. It's going to be a bit of a tight squeeze. It's just going to melt that. Yeah, so I'll just let it do it. We actually do want to make electrical contact with that particular setup anyway, so it's fine. Let it take off that insulation. Right, but those are not actually electrically connected unless I go and brutally burn off this insulation. With a bit of solder that's not been tainted by molten plastic. And now I think okay, it's not pretty, but it should do the job. Worried about this last one, but okay, it was the ground pin I actually needed to program, so that's alright, because the ground ones are the ones that look good, because that was, well, it was easy to take all the insulation off of that. Take all of that off, turn off the iron. We'll come back and clean up later, right? I mean, there's still solder residue from the original work anyway, so probably plenty of work with some isoclean or something. Yeah. Right, there we are. Okay, let me go get some male to male, male to male. Female. Male. Oh, okay, I've got a couple of random female connectors. I'm sure I had a whole box of those. They're all going to be... now look, what I could do is exchange this slightly fixed one. It's only 4 pin. Okay, I'm going to use that one for the serial instead, but it's only 4 pin. Well, 4 pin plus 1 for the other 5. Okay, alright, okay. I have a plan. Move all those without male to male. So those are also female to female, and I've got 2 over there. Those aren't. Any in my boxes? Ah, there we go. That'll do it. Right. Okay. These have probably all been used to connect up boards to serial at some point, the ones that are in groups of 4, right? But this one, I think, makes good sense to go do the TXRX, unless I need to cross over again, but I think I've taken the crossover out. Then I would only need to connect the 1 pin for ground. So it's actually going to make my life easier to have that, presuming that TX and RX are correct. Let's just check. I've got Putty running the background still. Let's take one of these and pull my CHPD pin up. Make that in here. Yeah, it's going, but I'm not getting anything on Putty quite yet. Maybe I was speaking too soon about those being... Oh, that sucks. That was wishful thinking, hey? That I hadn't crossed those. I obviously had done. I've done up here and not down there. I'm thinking that might be something I want to do on that board. Yeah, look, that was already set that way. There's me so keen to get that going. Okay, right. So that's boot mode 3. GPIO to 0. We bring that down to ground. And that puts me in. Okay, you wait a minute. It might be helpful if you guys could see Putty. Right, so we have a reliable boot mode 1. So then I can how GPIO 2, 0, 0, 2 and 15. So my understanding is, how are they hooked up? GPIO 15, which is I think the 4th pin along here. I'll tell you what, let's get a closer look at this just because I can. Alright, there we are. Hopefully you can see this one. So my understanding on the ESP-01 is GPIO 15, I think, is this pin here, which is being held down to ground. Hence we're getting something under the 4. Whereas GPIO 2 and 0 are going to be broken out to the pins over here. At the moment, 2 is basically left floating, so this is 2 up here, and I've held 0 low. Appears when they're left floating they take as being held high. Now maybe I want to specifically hold it high instead of leaving it floating, but 2 is also the one I've got set up to the output for the LED, which is, if it's floating high, vaguely on. It's not on brightly, it's just vaguely on. So hopefully that answers your question about how I think they're hooked up. I did spend a bit of time the other day just making sure I trusted that 15 was the right value. So it was checking the data sheets, checking the numbers, and just making sure there wasn't any of these pins that were not quite soldered in case, you know, when doing the other solder work I'd manage to dislodge them. Sorry, the microscope camera does not autofocus, so it's actually got a fixed focus, so I've got to kind of keep it at just the right height to make sense of it. Hopefully that answers your question. Pull up to the proper resistor. Okay, well, there are over here, these are a set of resistors, so I can do that. That's definitely doable. Let's just go switch to this one again, and I'll take the microscope out of the way so we can definitely pull up to. So Samuel Doy, one of my viewers, has just suggested making sure GPIO2 is pulled up properly because it has been left floating, and assuming I've got good contact up here, when I get booting Putty I should still see 10, yeah, so it shouldn't really make a difference, although that LED is potentially a little brighter. Oh, hello Paul, good to see you back. Awesome. And then I suppose we want to go for full screen will work over here. I have to disconnect this. Let's try and flash it. Oh, right, okay. And just to recap, we are flashing it with this firmware I found on my hard disk somewhere that I got built there. GPIO should go low for programming and high for reading from the EEPROM. Yes, that is my thought. Maybe I should be holding it high with a resistor instead of letting it float. So we'll try doing that afterwards then, since that's what all those resistors are there for. I don't know if you can see that clearly, but the blue light is blinking away while it's flashing, so that seems to be good. So maybe what I can do is, after I flash this, deliberately bring GPIO0 high. I need to let GPIO2 float because GPIO2 is what I've got connected to the LED, I think. So I have to check when I put the code on it later, because this is the tricky thing with that, I suppose. Yeah. However, it is connected to the other side of that resistor, so that's probably not such a problem. And there won't be much of a current going down, so if it went from input to output and started driving the LED, even with it being pulled down, that wouldn't be a problem, I think. I think that would be my thought. Yeah. Right, how are we doing? Nearly done. Alright, let's try and talk to it then. So, disconnect ground. Let's deliberately go and pull it up. And that means they're both pulled up. We'll put on load up Putty. Don't recommend floating pins at all while testing. Yeah, I suppose that's a fair observation actually. While we're trying to get it working, don't leave any of them floating. Okay, let's see what we get in Putty. Oh, there was plenty there. What's that then? Let's see. Maybe the flash has been successful, or maybe it's the version I've just used. I did have a bit of a change everything at once moment there. It's either the 9600 or 1152. That suggests it's not 9600. I'm getting some kind of echo. Again, this keeps opening in the wrong on the wrong screen. Oh! Hello! Ah, yeah. Well, so I was on the weird 7XXX, whatever, 74880, and that's where you get these messages. And then this came out there, but that must be what 1152 looks like, and that's 115200 there. And I suspect if I reset this, yeah, there's your bootloader, and there's Node MCU without an init.lua, which is fine because I don't expect to have one there. Okay, now that's something awesome. So let's see what happens, see if this still loads if I now float those two pins, right? Let's disconnect it. Let's take those two pins out. Except I've taken out CHPD, haven't I? It's that one I'm going to take out. So I've got those two pins floating again. Oh, I'm back. Hooray! So, okay, looks like it may have been the Node MCU version, but also why did it stop working when it appeared to have had code on it that worked before? Stream got out right when it got interested. My thoughts are, if I pull GPIO 0 down and boot the thing again, it should go into flashing mode, but it should not actually flash what's there. It should leave it alone, right? So we can verify that, and we can flash it again if that doesn't work. So let's go and first switch Putty back to that other baud rate. Apply that. We'll check we're in the right baud rate. So now it's still loading Node MCU. Okay. A hammer. Right. First, sorry about the streaming issues. I don't know. It seems to be. I don't know if it's a certain amount of time before something goes wrong, or maybe this is some kind of upload cap at my ISP, or some other unlucky factor. One of my viewers has just said, sorry, a hammer fell on my keyboard. I could actually well believe that. On second keyboard. Oh, okay. Right. Actually, a hammer falling on my second keyboard is exactly what things at the wrong baud rate looks like. So let's see, I've held this down. Way, hello. Right, that's with me holding that pin too high. So let's leave pin 2 alone. So what is this? This is... Oh, wait a minute. I think I'm supposed to be holding the other one low. Okay. There I am in boot mode 1. Now I'd seen these errors, and they might have been spewing out one of the other baud rates at the other time when I was trying to do it. So the question is has that every time if the stream went out every time the ESP gets started, that wouldn't entirely surprise me, because I am streaming and connecting the ESP-01 to the same the same laptop, the same device, so it's all connecting to one device. So I suppose if I manage to do something really horrendous and short something, this would all drop out. That's entirely possible. Let's hope that doesn't happen. Okay, I'm going to disconnect this, take out these two pins again, and let's see if it boots in mode 3 again, and if it loads anything. So mode 3. Okay, yeah, mode 3, and I'd be willing to bet that them garbage characters at the bottom there at 115200 is Node MCU. Yes, it is. So before I started doing all this messing around, oh, I'm slightly paranoid about that. That's how you make things go bang, so I'll get rid of that. Posted a comment with all symbols, second keyboard was one. Ah, I think Samuel, you didn't manage to post the message, which is just as well. All slashes. Plugged in a second keyboard for while I was winding a coil. I need both hands to wire it, so I'd be able to pause music with my feet is useful. Awesome. Wonder if it'd be a good idea. Wonder if you could build a foot pedal and maybe do I don't know, a Leonardo hack to get it to behave like a space bar on a music player. I'm pretty sure there's some example Arduino code that lets you make it behave like a USB keyboard, right? Maybe a push button Leonardo, or even a big button for your foot. That'd be a fun hack, right? That'd be fun to try. Okay, so we've got this to work, but now I'm trying to determine really what went wrong. Why, when I brought this back, why did it die? I can go back to this view perhaps so we can see a bit more. Why did this not have Node MCU? There is an init.lua that would have been on there initially. Now what's in that init.lua here? That's not the one. I'm just gonna... Oh, okay. Sorry. Slight geek in me coming out. One of the well, I'm sitting here learning electronics and microcontrollers anyway, but one of the other viewers, Paul, has just posted he had a friend who made a pedal for the Meta key in Emacs. Yes. Awesome. Tired feet, very tired feet. Foot pedal to control a mouse button. Oh, I like that. Oh, the things you could do if you could kind of put modifier keys on a foot pedal. That's awesome. Foot pedal 3 finger? No, that's perhaps that would be too trigger happy. Right, reboot. Bang. I'm just gonna have a look at what's going on in this. I got an init.lua here. I just want to check what's in there. For a start, okay, no, that init.lua doesn't have anything interested in. One of these has potentially got my Wi-Fi key, so I'm not going to put that up on the other screen yet. Let me go find. I'm going to try. I've got the original code for this, so it's possible also the original code did something. There's my folder, all my repos. So the original code was actually on GitHub as well. I'll see if I can go and find the GitHub link actually. It's not that one. So if I switch to so this, I'll put that in here. That was the original code. The pedal itself is an old flip type address book with the page removers. Sweet. I've never gotten into the idea of doing I mean, audio effects pedals have got to be quite easy, I suppose, if you kind of connected an audio, connected to some kind of, I don't know, VST plugin or something, because I do make music. So you can make maybe a pedal controller using an Arduino Leonardo. I bet there's code to make it also emulate some kind of MIDI device. You could just do a MIDI input controller as well. Ideas lighting up here. Right, so this one here, Web LED, would have been the original code. And this one, LED server, this was almost certainly the init.lua that would have been on there. I mean, I'd be, yeah. So pin 3 is GPIO0 apparently in this code. Serve HTML, set LED. Did originally make it as a staying pedal for my keyboard. I've just done a MIDI controller, not with a Okay, cool. So you actually did make it a pedal for the keyboard. That makes sense, because they often do have a headphone jack thing for the sustain pedal on the back. I'm pretty sure my keyboard just uses that. I don't know. I suppose the pedal came with the keyboard. I connected it and forgot promptly, but I should check if it is just a headphone jack style thing. So part of me is wondering here, if I'm holding GPIO 0 low as soon as this init.lua goes, serve HTML, serve listen, there's no serial to say it's doing anything. And if it hadn't managed to get hold of the Wi-Fi, hence I think since I did this, potentially I've changed my Wi-Fi passwords, then that might have been actually, it was sat there doing this, running this code and not outputting a peep. And the problem is I can't tell. I really can't tell, because the first problem with this code is, and I suspect this was me taking sample code and adapting it, there is no output, not a peep. So I think what I'll do is perhaps use Explorer. Explorer is quite nice for uploading and interacting with the ESP device. Usually 1/4 inch. Okay, so it's usually a 1/4 inch headphone jack for the sustain pedal on a keyboard. Okay, 3.5mm to 6mm adapter. Okay, so one of the, okay, because the quarter inch is the 6mm, is it? Yeah, cool. So let's see if I got Explorer somewhere here. I must have. I may as well close this. That's done its job well. Thank you very much. And I'll just see if I can find out where I've got Explorer sat. .6mm is 0.2 Imperial Fun Units. Okay, 1/4 inch. I like that. Imperial Fun Units. Dare I ask what the fun is? Right. So I've got Explorer here. And it's worrying that jar isn't doing anything, because Explorer obviously being Java. Okay. Let's get myself a command prompt up. Let's go here. And let's see what message was briefly flying up over the screen there. Now I'm partially wondering. Oh, Windows. I use a combination of Windows and Linux at work, so there's some stuff I like. Oh, I don't have Java. That's really okay. I'm surprised by that, but I guess I'm just going to go and grab a version of Java for Windows. Windows 10 and Java. Internet Explorer will continue, Edge browser does not. Java. Where is it? Just going through the Oracle website to find a download for Windows Online. I am mildly shocked that I've gotten this far on this relatively new laptop, I'll give you that, without having Java on it. I suppose I just kind of assumed it was there. I mean, you know, why wouldn't it be? Is that it? No, here it is. Right. No, I do not want any other junk. Thank you very much. I guess this is them just, they're there. Let's find some way to make some money on this as well, since it's free. But yes, I definitely don't appreciate programs that try to do that. I don't know. I get that they're feeding themselves, but yeah. Right, do we have Java? So what I'm going to do is, now I'm not expecting it to be in the path yet, but am I going to be able to just simply start up another command, and am I going to be lucky enough to have one? Yay! Okay, and if I'm even luckier, I can double click that and off we go. Right, okay. I did not want to close that window. Have my code in there. Let's and let's just navigate through to where that, no, that's not where it was. I can make my sound better if I turn off the there we are. And to install Java the first time on this Linux box a week ago. Yeah, I suppose it's just one of those, you know. I've generally got Python installed everywhere. I should normally end up with Java installed there, but somehow on Windows I tend to like, I don't know if you've come across the Night installer. I haven't gotten into using Chocolatey, but I keep hearing about it. Apparently it's like Yum but on Windows. Hurrah, very funny. But yes, I do quite like the Night installer, where you can just kind of go click on a bunch of different tools and install. Right, Web LED, LED server. Well, let's open and let's go down just oh, lovely. I think it's gotten easier to get Java installers and JDK installers than it was, because I don't know if that's changed, but you used to go and have to create or have an Oracle account to go and get yourself the JDK to use on a system. So you had to have create a username and password. Help desk and no. I suppose I mostly use it when installing desktops. There's so generally that's only for me and for another developer or something. I generally kind of steer them that way. We do have some servers at work that run Windows, and currently the tool that someone's picked for that is PDQ. There's a rant on one of my non-robots blogs about what I think of PDQ. I mean, I don't know, it works, it's scriptable, it's an automation system. The thing that frustrated me is it's utterly incompatible with Git or any kind of source control, which, again, rant for another day, but I swear by using source control everywhere. I mean, it used to be it's been SVN and before that CVS, but Git this time. Oh, help desk at college, yes. It's a good little evening activity. I used to, when I was back at uni, I used to be do help desk there, actually. Right. just again gonna quickly see. Have I got the right code? Okay, let's start off with this. So that was what I was looking for. I'll tell you what I might do. Let's see if I can get this to capture it. My experience with help desk, professors' computers. Oh, that's kind of. I ended up doing a help desk on a campus that was not the computing campus, despite that being my main campus. The campus I ended up doing that on. I'm going to have to disconnect Putty here, aren't I? Otherwise it's not going to play ball. Hooray. I ended up on the campus that was had the psychology students, and I'd been doing, I was doing AI, cognitive science, that ended up being part of psychology. And one of the problems we had with help desk was sometimes someone would arrive and they'd be absolutely hysterical about a problem. And they weren't the computing students, so they'd absolutely freak out. And sometimes it was just that it probably dates me, but Clippy had stolen focus and they couldn't get back to their Word document. But you had to calm them down before you could get any sense about what was actually the problem. And yes, Clippy. Oh, not sorry to see the back of that. Right, now what was the what was the ESP serial? It's just print. So let's stick some print statements in this thing. Print setting up, because why wouldn't you? I mean, even if it's running headless, the print statements are just going nowhere. It's fine. At least they're running. Did I need brackets, don't I? This is Lua. Yeah. Does print need to be print line? Print hello. Doesn't, does it? No. Right. This is probably going to get real boring real soon, so we'll just, as in that's gonna, we're gonna spam us once it runs. Yay! And yeah, there we go. Cool. Okay, so that's all right. What I'll then do, and I apologize for this, but I'm going to just take that out of view because I'm going to feed it my contact details, Wi-Fi details. Oh, wait a minute. Actually, when this was running, did it actually blink? Hold on. Just do the save and run a thing again. Hello. Ah, I maybe want to get a newer version of Explorer. Let's just see. Yay! Look, that's working beautifully. Okay, that's something. Because I didn't really check that. We'll send that. Okay. So I'm going to just take that off screen for a second while I go and feed it my Wi-Fi station details. And do I even have them? I mean, I think Oh, okay, this is interesting. So I haven't actually got the, I'm not actually doing the passwords in yet. I was just doing a list of access points. But soft AP. Now, so software access point. Okay, that's different. And yeah, okay, so there's just a something like this. Then we can try that again. Oh, okay, right. Well, okay, that's an so I should be able to connect down here. Do wi-fi.sta.config. Just trying to just trying to find my Wi-Fi key. Okay. So I guess the next question is, and this might be me finishing on at least some kind of high note, can I get this to run the original web server code? So I think it was LED server. And let's stick some print statements in. So, oh, there's okay, no point there. So print initializing. Creating server. Listening on port 80. I would rather also it did. Oh look, so there's a print payload right here, and I reckon I should get it to print its IP as well. So I got it only printing when it got to there. String.find in payload on. Yeah, you know what? I'm just going to print the payload regardless, because right. Now how do I get it to tell me its IP address? I can't remember that, and I might want to print that here somewhere as well. So let's just node MCU API STA. And now I'm just gonna, so if you've not searched this recently, that link at the top always doesn't get you to the right place. Always go to the node that read the docs node MCU documentation. The original GitHub wasn't moved there. It's still the top Google hit, despite the fact that it just links you to this next page. Okay, and I think it is Wi-Fi, is it? What's my IP? Do we have get IP? So let's see if it really has got an IP. Oh, I've got to print that, haven't I? No? Okay. That looks viable to me. So you know what, let's put that in there as well. Now it's not going to be able to listen because it's already listening. Only one TCP server allowed, which is fine, that's cool. But now if I go to HTTP that, I got lights there. Oh, and I got a reset. That's interesting. So this is obviously doing some kind of mode switch here. Connection keep alive. Unprotected error call to Lua API LED server Lua open 10 file.read file what.read. So there is an error there. Okay, well, we'll take that out then. And this should be con.send hello node MCU1, right? No? On sent function con close end. So what? Print sending hello. And now how can I tell it to stop listening? This is in the service net create server. So let's look. I mean, we're at a point where this is thoroughly working. I haven't determined what made it stop working, but there's entirely a possibility that because there was no serial in that, I mean, this is no longer giving me a prompt. Oh yes it is. Oh hello. So it's running and prompting me. Nothing hot, that's good, nothing running hot. So it's running and prompting me, so that's that I would have expected. So yeah, that still doesn't that doesn't explain that why it was got. It wasn't simply running mute. Unless of course it had some code that had some other error that made it not work, as in startup and then fail almost immediately with one of these panic messages, because that panic message caused it to actually reboot. I mean, that's, yeah, I think. Okay, let's try /on. Ooh. Oh, hello. So that thoroughly works. And that's entirely what this board was originally supposed to be able to do. Did I disconnect the ground from GPIO 0? Yes. At this point, ground is not connected to GPIO 0. So 0 and 2 have been left floating. So yes, it'll happily do on and off up here. And if I just put that a bit closer, so if I hit enter, there we go, perfect. And I think that file.read is, I may have been getting it to serve a payload that I'd uploaded, which I think was a file with HTML file with some fancy, well, not fancy buttons, but something like that. So there was a file that I uploaded, Power LED HTML, and that would be then when I do that bit. Okay, I'm going to copy, send just that block to just override that one function, and then if we go up here, bingo, there we go. That was why we were getting the file that wasn't there. Unfortunately, it starts in the on position, so it's not at there. There we are. So that's all working as I expected it to. So we've debugged it, we've got it working. I'm not satisfied with one thing, which is I still don't know what went wrong with it first, as in why it ended up in a state when nothing was happening, like where it was at this other baud rate and doing nothing expected. But I think I've been talking now for 2 hours tonight. I'm happy at least that we've gotten this far. Let's go, and that this thing also works as it's supposed to. Yeah, okay, so we've gotten this far, we've got it to work. I think, yeah, thank you for the suggestions of soldering stuff in and soldering a headers in. I suppose there was a point a while ago where I thought maybe, but I think that was, I had to do that. I had to get to something where I could actually put bits in and debug them. We didn't get to use all the toys, we didn't get to use the oscilloscope, but I wasn't entirely sure how I was going to get the oscilloscope in shot anyway. But we did get to play with the microscope, so there's some quite it was quite nice seeing the ESP in the microscope there, I think. And I suppose now that works. My probably next live thing, I'm going to be playing with that JDY-08, the USB board. Although there was a second design for this, and I think if you saw that layout video, there was a video where I talked about perhaps sticking a don't question it, just leave an offering for the electron gods. Has anyone seen is it the Mike's Electric Stuff, where he does I think it's a 10 gigahertz transmission system teardown, and I think he does a sacrifice to the electron gods, or yeah, you know, take precautions. No, not those, silly. It's a great moment. Mike's Electric Stuff. I can't remember the exact video. I'll have to find it and maybe post a link to it. Yes, so I'll do the JDY-08 thing, and maybe for something on the back burner to try, I'll it is beautiful, isn't it, the resistor. I'll maybe consider the RF voodoo gods. You've got it, you got the one, that's it. I was talking at some point about hooking this up to one of the Max 7219s, or making a version of this board, perhaps sticking these headers on from the outset, and maybe not repurposing this board, making another one, so I can get some scrolly text, you know, that has whatever I want on it, big, you know, recording, or one of those WS2812 panels for multicolour recordings, where I might be able to sneak that behind the panel, so all you can really see is the panel with maybe the thickness for batteries. Maybe. You were thinking of the scene while writing the comment. Awesome. Well, okay, job done. Yes, so sorry, it was Samuel Doy at the top saying don't question them for just leave an offering for the electron gods. I suspect there have been plenty of burnt offerings in this particular debugging session anyway. I mean, you've only got to look at the bottom of that board to see some of the horrible bits and the discarded things. Right, thank you for watching, everyone. I'm kind of glad we've gotten to a this works result. I'm, you know, pleased with that again. I mean, the only thing really to say is that LED's not that bright. It's only a little thing. Might be brighter if I could run it directly off that 5 volts, I suppose, but that'll mean a transistor at some point. I love how it seems all of us are watching the same videos. Oh, awesome. Thank you guys for watching, and I'll see you on my next live stream. I'm also going to try and get some of my recorded material edited and published, so hopefully there'll be more of that. NeoPixel, yes, WS2812, it is the NeoPixel. Max 7219 is a LED 8x8 LED array with a controller chip, but actually I think they're not as bright as the NeoPixels. They use more current. They're slightly harder to interface with. They're just an older thing, right? But I've got a bunch of those lying around, whereas I think I've only got two of the 8x8 NeoPixels. Anyway, I'll leave that for next time. Good night all.